Is this working? All right.
Okay, it seems to be. Yeah.
Yep, sorry, new setup. It's bound to have issues. Right, so let's do it again. Hi everyone, welcome to this PopcornFX 2.19 live stream. God fucking damn it.
Okay, yeah.
Right.
Sorry for the sound issue again.
Yeah, so release-wise, we'll see the current releases. So this week we're releasing 2.18.6, which is the last version for 2.18, and 2.19, which is the version we showed at GDC and contains all the cool new stuff. And the next release will be 2.20 in roughly 4 months, which will be the next long-term support version. Last one was 2.15. So yeah, that's the rough roadmap. Next one in 4 months. So first, the new simulation features. So in 2.19, we're introducing two new simulation features, which are grids and fences. So grids are basically low overhead arrays. Before that, we had what we called the spatial layers, which were a 3D hash grid that you could query using positions and a sphere to gather neighboring particle information, and with that you could do a lot of things. Most of the effects we're showing, you could kind of do them with spatial layers, but the overhead was pretty significant for the cases where you don't really need to access spatial neighbors and where you just want to use an array, basically. So these grids are available as 1D, 2D, 3D, or 4D. Why 4D? Because we noticed that usually it's useful to double buffer some of those simulations. So in case you have a 2D simulation, you would use a 3D grid with the third axis being, with the third dimension being 2, for example. So for the two 2D textures, basically, and same for the 3D grids. The fourth axis would be an index into multiple buffers, or yeah. So here on this GIF, on the first one, you can see a 2D shallow water simulation, which uses grids. And the GIF below is a dripping example, which each frame samples the mesh, the skin mesh UV, and will write into the 2D grid at this location, causing these trails to be written. And all the grids can then be used inside the engine and bound as textures in shaders. So you can then use this 2D grid as a shader mask to change the material or stuff like that. Same for the 2D shallow water sim, you can bind that as a height displacement or something. And on the right here, you see all the new helper nodes for grids. For those of you familiar with Unreal's Niagara, it's basically the same thing as a Niagara grid. It's low overhead access arrays. Next one is fences. So for most simulation, when some particles need to access the neighboring particles, they need to be sure that the neighboring particles have finished updating and writing to these locations. So fences are like GPU barriers and allow you to say that, for example, this rope constraint node has to wait that for all the particles to have finished updating the motion Newtonian node. So this will ensure that whatever reads are done in this node will read data that has been written by other particles in the simulation batch. So here, for this rope example, you can see the various simulation steps here. So first the position update with the velocities, then we run 3 constraints step, which all wait for one another. We still don't have loops in the graph, so this would otherwise be done in a loop, but because we don't have loops, we copy paste 3 times the constraint node, and we use fences to ensure that the data is available for the next iteration.
So before moving on to the demo, we'll just quickly remain on the topic of newly added things to the core lib. So here you can see a bunch of new templates that came out recently with the v2.19 that are mainly here to improve the user experience of artists, usually by building upon existing functions or simply adding some new helpers so that things are a bit easier or just take less nodes to compute. So you can see here the 2 rand switch and rand peaks that basically iterate upon the new random peaks that already existed in the previous versions. We added as well a distance between 2 vectors. So this node here basically allows you to calculate a distance, like several kinds of distances between 2 points or two vectors, as well as some horizontal and add and multiplication that allow you to add or multiply all the components of a vector together. So something you could do easily before, but now it's all templated into a helpful node. Something that was requested a lot as well is this has changed since last frame, which allows you to work with discretization a bit more easily, so that you don't have to do all the computations yourself. You can just see quickly if something changed or not since the last frame. So it's useful to watch some evolution in your particles. And there are also there's a handful of new texture sampling tools. So you can see some of those on the right. It's not exhaustive, so there are a few more. Either adding new features or simply building on top of already existing features to allow you to work a bit more in depth with the texture sampling in your particles. So now we will move on to the demo, the GDC one, showcasing the simulation framework. So this demo is entirely built using Unreal Engine and integrating PopcornFX particles. So everything that you will see, all the cosmetics here, are actually popcorn particles using, well, for most, the new simulation framework. So the first feature that we want to showcase with this demo is the ability to create some kind of rope solvers. So here, when I shoot those 2 light bases, you can see that it spawns a rope, which is actually entirely made of particles. So the particles are here simulated in PopcornFX and used as, let's say, joints or more, vertices for the rope. And then it's displaying on top of that ribbon tube renderers to actually make it look like a rope. And so since it's all made of particles, you can see that we're spawning additional particles on top of that. So those small lightnings, those small sparks that give impulses to the rope, as well as some occasional lightnings that recast the actual level. So it's nothing pre-baked, it's entirely made at runtime. So you can see that if I shoot something that's not between those 2 light spots, it actually creates a rope that destroys itself and then spawns in turn additional particles. So those particles here are once again popcorn particles, so you could add whatever you would like to these. Here they are simply using a dissolved shader to show that the thing just didn't work.
So yeah, the point of those simulations is not to replace what you would have a physics engine do, like high quality rope simulation. This is actually a very cheap rope simulation. It doesn't do a bunch of things, like it doesn't collide with the characters. It uses basic raycasts to collide with the scene. This one is running on the CPU, but it could run on the GPU, and the GPU collisions could use depth buffer collisions instead. The point is really to have a low overhead rope sim for when it's not really needed to have a more complex simulation. You could also use that in conjunction with LOD. So the built-in LOD we have in Popcorn can be used in that sim to lower the tick rate. It could also be used to like replace a proper physics rope close by a cheaper a particle-based sim when the rope gets further away. So yeah, it's really provided as an example of the kind of simple sims you can do with the new stuff.
Another effect that we wanted to showcase is this dripping effect that you saw earlier in the editor. So here there are actually popcorn particles again falling from the roof of the room, and those particles are colliding with the skin mesh. So and then once they collide, they spawn the particles that are actually sampling the mesh that you saw earlier, and these are dripping along the skin mesh, then writing in the render texture that you saw. And this render texture is used as the material map for the character. So it's sampling whatever is in that texture and then displaying the acid or this rust mask that you can see. So it's allowing you to have real-time interaction with the environment. And another thing that we added on top of that is that those particles can actually inherit the velocity of your character that is displayed by those small yellow velocity vectors, so that if you move quick enough, they detach and they can spawn in turn those small decals, for instance. But they could spawn whatever you would like, since it's not a closed system. Those are particles that can interact just like your regular particles.
Yeah, and something interesting to note, you can see the ropes at the back with the glitches. This is one cause of using the simple raycasts, is that it's not colliding with the segments, it's just doing collision on the points between the segments. So here at this location there is a physics collider along the wall that messes up the collisions. So this is the kind of artifacts you get with the simple sim. It's super cheap, but yeah.
And another example that we wanted to show here, once again something that you could do, is this shallow water simulation. I will quickly relaunch it.
Yep.
Because the build version seems to have a few issues. Okay, so here we are. So as you can see, this is more of a proof of concept of things you could do. So here, so here you can see the actual simulation. It's the one again that you saw in the editor earlier. And here it's using the character position as the effector to disturb the simulation. And here we're not displaying any particles. We just are displaying a huge mesh, like this square mesh, that is actually being displaced by reading the values that are in the render texture. So here used to give this kind of oily effect. But it could be, here's the debug view, it could be whatever you would like it to be. And once again, since this simulation is driven by particles, it can not only displace the mesh, but you could also spawn additional particles on top of it, have some splashes where the character moves. You could add additional effectors to have one per leg, for instance. So there's a lot of customization you could do. This just to show basically what is technically feasible. Anything to add on this one?
No, I think we're good.
Okay, so let me switch to the second thing that we showcased during the GDC. Okay, so once again, more as a proof of concept. This was something that was targeted at studios that do racing games. But it could, again, be used in any kind of situation, since it is the simulation that you would actually want to build. So you could build anything you want with this, or iterate on top of the existing solver. So here we're actually showcasing a thin film fluid simulation, where we basically sampling the mesh and doing a particle simulation on top of the windshield and the left window mesh. And then we're once again writing a render texture. So here there are no actual particles being displayed, apart from the rain in the background. But the drops that you see on the windshield are no billboards. They are simply values being written in a render texture that is then being used by the mesh to here change the normal and the refraction intensity of the mesh, but it could be whatever else you want. And you can see that it's reacting here to the wind, the wind speed that could represent the speed of the car, and to the wipers as well. So yeah, this is once again not a fixed simulation. You could do whatever you would like with this type of simulation. It's just an example of interaction between the scene and the particles.
Yep, all these are examples of how to use the fences and the grids together to make stuff that was pretty hard to do before. And this entirely runs on the GPU, so binding this texture afterwards in the shader to use as a distortion source is pretty cheap as well. It's basically similar to what you would get if you were to write a compute shader by hand that did the same simulation, because the popcorn graph generates a compute shader, and this is running fully on the GPU, so there is no significant overhead compared to a handmade version. So now I'll quickly show you a few of these effects. Already
sorry.
open. So maybe I'll start with the dripping. Yeah, so here we can see the debug view of the texture behind a few vectors that show the mesh normal, the surface velocity of the mesh. And here in this debug view you see what gets written in the texture and what the shader gets afterwards, and that's how we lerp between the rust material and the base effect material. So here in this graph you have CPU particles that drip onto the mesh. They get reprojected each frame on that mesh, and then they trigger a GPU write. So here we read the value of the grid, accumulate whatever value we need to write at this UV location, and write it back. And here we have 4 writes. This is just to get anti-aliasing for the 4 texels around the point where we want to write. And finally, this grid update layer here, there is one particle per texel. This can be scary, but it's not a particle like a position, velocity, and renderer. It's actually just a thread in the compute shader, so it's efficient. And here this update reads the grid value, decrements it by the scene delta time times the fade speed, and that's what causes the trails to fade. Like if I set the fade speed to 0, you can see that the texture just gets overwritten. And yeah, this is what fades it based on whatever is set in the game engine side. And then we write it back after clamping it. So pretty straightforward. Now we'll show you the rope sim. So this one becomes emissive after 1 second. This is just so we get the Unreal material working properly with the light up that it has. We don't see it here, but so if we look at the effect, there is a whole bunch of stuff for all the sparks, the lightning, and things like that. Also the breakage into segments when the effect stops here. But the base rope is basically 2 layers. Well, 1 template and 1 layer. This is the solver node, which takes care of the actual simulation with the grid and stuff like that. And this one just draws it as a tube ribbon. So tube ribbons are a 2.18 feature. I'll quickly show that here. So I don't know if it will be very visible in the stream, but here you can change the tessellation of the tube, like a 3-side tube or a 13-side tube. Anyway. So in this simulation template, if we open that, this is where one of the screenshots of the PowerPoint before came from. So here we have 2 simulation steps with a fence in between. And if I open one of these, here you see the physics update step, the constraint steps. If I open the constraints, you have 2 distance constraints, 1 bend constraint. Yeah, this is a bit messy. It's not really meant to be pretty here, but yeah, just as a proof of concept that it works, and it works. I'll let Raphael show you a few of the new editor features now. Oops.
Yeah, sorry for that. Yes, so in addition to the new simulation framework, there are a few updates as well to the node editor that are mostly quality of life and UX improvements, simply to make using the tool a bit easier. So the first one that we have is something that you might have seen already in some other node graph editors, which is the ability to move in the node graph by reaching the borders. So in addition to moving with the mouse wheel, you can now reach the edge, whatever edge you want, with either a node, or if this is out of reach, with a pin as well. And you could just move through the node graph that way. So it's something you might already be used to, and it's something pretty useful. Another feature that we have here is the ability to change the inputs, to swap the inputs of two simple two-input nodes. So I think that Rancel has it, for instance. By pressing the X shortcut, you can swap the A and B inputs, but it works with the mul as well here. Or if we have a plus, like an add, it works as well. So basically, most of the two-input nodes allow you to do this. So here with the lerp, it works with the if and select as well. So it's something, again, just a quick shortcut to gain you some time. There's a new update as well regarding visibility overall in the graph to try to make things more readable. So now when you hover a pin or a wire, it highlights what is connected to that wire, and allows you to see exactly, first of all, that one is selected, so that's why it's highlighted. Yeah, so it allows you to see whatever nodes are contributing to that specific wire or the specific pin. So it can be useful to see exactly where the behavior is coming from and to isolate behaviors. And also it allows you to make your graph a bit clearer if you have some overlapping wires. So this is something you should try to avoid, but in case you have this type of stuff happening, so here you can see that the mul is not actually connected to the value A. It's something that you try not to do, but in case you do, here by hovering the A value, you can see that the wire is actually not just going through the node, but not using the multiply, which can be useful to debug whatever is happening. You can see here the B value is actually using this. So yeah, again, just a small quality of life feature that might make your life easier. We also added something regarding annotations, so you can still annotate with right-click, annotate, or with Control-Shift-G. And when you do, if you have the sticky option ticked here, it not only allows you to move the nodes inside it, as it was already previously the case, but also now if you copy and paste these annotations, if they are sticky, whatever is inside them will be pasted as well. And as well, now if they are selected and sticky, you can Control-Delete instead of simply deleting them, and whatever is inside will be deleted as well. So once again, just to gain some time while editing your graphs. I think that's all the major changes for the node editor. There are a few minor ones, but those are the main ones. And there is something else we want to show you, which is now in the editor preferences. So here you have the post effects that you had before, and now you have the new option to actually use project settings for the post effects in the editor, which allows you to have general project settings, and you can override them if you want, if you untick use project settings, but by default, if that is on, it allows you to have something that is more coherent between all your effects in a project.
Yeah, so this is mainly if you're using, for example, Unreal or Unity, and you want to tweak the post effects to kind of match the look of that engine. It's now in the project, so you don't have to redo it every time. And this was previously per per user, so it would be a pain in a production to have everyone set exactly the correct PostFX settings. So now it's in the project settings, which is supposed to be pushed on the repository, so everyone gets these PostFX settings.
And talking about PostFX, we added a new one that is the color remap. So again, it can be used in project settings or as a standalone one for a simple editor. So here, if you enable it, I will take one of these, and here you can see we have, like, we applied the greenish lookup table, which is basically turning, like, shifting all the hues in the editor. So again, if you want to match something that you have in your engine, it can be a handy, helpful way, to quickly replicate that look without having to tweak your colors, and simply to try something new and see how things look with a new color. You can quickly swap those lookup textures. I think that is all for the main editor and node graph features.
Yep, that's all. If you have any questions, we'd be happy to answer. Oh, I'll switch back to the cam maybe.
Yep.
Wait.
There we are.
As always, we're on the Discord, so if you have any questions, hop in there and we'll be happy to answer. Hey, thanks Hugo. Glad you like it. Well, if that's all, we'll end it here, and thank you for joining, and see you next time.
Thanks, everyone.
Bye-bye.
Bye.